Assalamualaikum and a very good day. So today we are going to learn on the Poisson approximation. So what is the Poisson approximation? So when we have the binomial, then we can approximate the binomial to the Poisson. With the mu is equal to np. So when can we use this Poisson approximation? So there are two properties that we must fulfill to use the Poisson approximation. The first is that your n must be greater or equal to 30, and the second rule is that your p must be less than 0.1. So from here, your binomial we approximate to the Poisson with your mu is equal to np. So this is the Poisson approximation. Okay, now we look at this example. Okay, so from this example, we have 1000 from a supplier. That means this is our n. And we have the probability of any one engine from the supplier proving unsatisfactory is 0.001. So from this example, we have the binomial distribution in which we have the value of n, which is 1000, and we have the p 0.01. Okay, now if we have the value of n in which greater or equal to 30, in which n is equal to 1000 is greater than 30, and we have the p less than 0.1, okay, in which our p 0.001 less than 0.1. That means we can use the Poisson approximations. How to use the Poisson approximations? Our Poisson approximation, our mu is equal to n times with the p. Okay, now our n is 1000 and our p is 0.001. Then we get our new mu is equal to 1. Okay, so our Poisson approximation is equal to the mean 1. So the question asks you what is the probability that none is defective. That means your x equal to 0. So what is the probability? Okay, by using this Poisson approximations, okay, our x equal to 0 is equal to e exponent negative mu, in which your mu is equal to 1 over mu, our x is 0 over 0 factorial. Then we get the answer is equal 0.3678. So this is the Poisson approximation. Now we look at example 16. Okay, so on average, that means this is your mean. The number of prepaid card was sold is 8 cards per hour. So we have the unit of measurement in hour. So that means our mu is equal to 8 in hour. Okay, so assume that the number of prepaid card was sold at the shop is approximated by a Poisson distribution. Okay, so the question already asks you to use the Poisson approximation. So what is the probability that there are 7 cards are sold in an hour? Okay, now we have to use the Poisson approximation. Okay, because the question already asked, so that means we have Poisson, and the mu is 8. Okay, in hour, because we have the unit of measurement in hour, given in hour, and the question also asks in hour. So there are 7. So what is the probability that there are 7? So we have to substitute, okay, this x equal to 7 in the Poisson distribution formula. Negative mu, our mu is 8, mu, our x is 7 over 7 factorial. Then we get 0.1396. Okay, now we go to the question B. More than 3 cards. Okay, more than 3 cards, that means x greater than 3. Okay, so what is the formula? Are sold in 15 minutes. Okay, now from the questions you are given 8 cards per hour. Now the question asks you in 15 minutes. So for in 16 minutes, that means 1 hour, the card sold is 8 cards. Okay, now how about in 15 minutes? So in 15 minutes, there are only 2 cards sold. Okay, so we have the new mu or new mean of your Poisson distribution, which is equal to 2. And the question asks when our x greater than 3. Okay, so when your x greater than 3, so if you use the theory 5, x greater than 3 is equal to x greater equal to 4. Then you can look at the Poisson distribution table when your mu is equal to 2 and your x equal to 4. Then you will get is equal to 1429.